notes too. All right, so the first thing you want to do is get a common denominator. Most of the problems we've seen so far, the bottom's been pretty much factored out, but if something's, you can factor it, you definitely want to do it. So like this first fraction, that's a difference of squares. So that really factors into that. So if you kind of look at our common, like the denominators we have, like a common denominator that we could get all of these to be is basically to have both of these binomials. So we see the first fraction already has the common denominator, but the other ones we're going to have to do a little bit of work too. So the first fraction, I'm just going to copy like it is. If I'm trying to get this second fraction to have this common denominator, I need to multiply the bottom and the top by x plus 3. If you want, you could just kind of distribute that to begin with. So if you do distribute that 5, that would be 5x plus 15. And that's going to equal our last fraction. Oops, let me change the color back. So we want this common denominator. Oops, I used a different shade, but oh well. So if you look, this last fraction, we're going to have to multiply it by the x minus 3 binomial. And if you want to go ahead and distribute that 3, save a little bit of time. But now that we've got all our fractions over our common denominator, we can just eliminate them. Really what you're doing to do that is you're really multiplying everything by x plus 3, x minus 3. So basically that would cancel out all your fractions. But that's like the reason you can do that, because you're doing both the same thing to both sides of the equation. So it's totally legal. But basically we're just going to write what we have in our numerators. You can combine like some like terms, and if you wanted to kind of like do that all, like save some steps, you can feel free. But then we just need to solve this basic equation. So I'm just going to get the x's to the left side, and I'm going to go ahead and move my constants to the right side. So that would be 2x equals negative 9 minus 17. That would be negative 26. Divide by 2. You should get x equals negative 13. And like I said, you just want to make sure this isn't extraneous. All you want to check, you just want to make sure, and sorry, I know I'm erasing some stuff. You just want to just double check. If I plug this into any of my denominators, does it cause any issues? But you'll see, like, I mean, if you plug negative 13 into all those bottoms, like you're going to get a number. You're not going to get 0. So that's really all you want to be careful for, because sometimes you might get a solution that would actually be like a vertical asymptote or a hole, if you kind of remember way back from 8.3. So you just want to make sure. That's really when you're checking for extraneous solutions with a rational equation. That's really what you want to be on the lookout for. So just be careful with that. Like for example, if we had x plus 13 on the bottom of one of these fractions, that would be an issue, because that would equal 0 if you plug in this negative 13. But it is not, so this is our solution. So I'm going to skip this word problem. I mean, if you want, when I upload the notes, I'll like put this worked out, just in case anyone's curious. But like I said, you're not going to see this on you're not going to see any word problems in the Delta Math or on your test. So I figured I would skip it. The last thing I just wanted to show you guys is how you could also use a graphing calculator to solve these. On your test, I mean, most of you guys are probably just going to do the algebraic way for all these, but this is just the method, just so you're aware. And what I'm showing you also, this would work for pretty much any kind of equations. Like even with like, if you think back to like systems of equations, if you don't want to do this algebraically, you could graph both of the lines, but you're going to be looking, when you graph these, our goal is to see where these intersect. So we're going to, if these truly, we want to figure out where these equal each other. I want to figure out where this equals 5. So basically, we're going to graph each side of our equation and look for where they intersect. So we're actually going to graph 2 different functions. So the first thing we're going to, let me write it like this. Like in our calculator, if you remember, like when you graph stuff, it's like y1 equals y2 equals. So we're going to graph this x plus 2 over 1 minus 2x. And we're just going to graph this 5. So I'm just going to write these down. I do got it written down here. Okay. So If you actually have a graphing calculator, or if you're using like this Calculate 84 app or like another graphing calculator app, let's clear all this junk. But you'll press the Y equals button. I'm just going to clear. Oops. If you have anything already in here, just clear them. One thing you got to be careful when you put a fraction in, you want to put parentheses. So if you remember, our first equation was x plus 2. And if you don't remember, this button here is how you type in an x, just in case it's been a bit. But then you're going to divide it by the bottom of our fraction, which was 1 minus 2x. But make sure you put parentheses around the numerator and the denominator, because if not, it won't realize that it's like all of the top over all of the bottom. So you do need to like type it like I have here with parentheses. And then our second line is just going to be the y equals 5. So then we're going to press the graph button. You're going to see on your, if you have like a TI-83, it's not going to do different colors, but in this app, it kind of graphed our first line, like our first function in blue, and our second function, the y equals 5, obviously is a horizontal line. So you can kind of see where they intersect, and you can kind of move your cursor. You can kind of get close to it. On a graphing calculator, it's really not as possible. Like if you have like a TI, like what's my calculator? You actually have one of these calculators. Obviously, you can't use your finger to get like super precise. So we're gonna have to use. There's a function. If you press the second and trace button, you're gonna see that one of the options is intersect. That's the option we're gonna be using. So when you do the intersect function, it's going to do this left bound and right bound. It's kind of weird how there's 2 x's on a regular graphing calculator. I don't think there's 2 x's. I could be wrong, but you want to make sure when it says left bound, if you kind of remember when we did this, what did we do this for? I think minimum and maximum we did this before. Left bound, you just want to be to the left of where it intersects. So if you see both of my x's are, I'll just check. I thought on a real graphing calculator it's just 1 x, but maybe I'm probably wrong. And then right bound, you just want to make sure your x's are to the right of where it intersects. So like, for example, here it looks too close to me. I'm just going to press the arrow one more time, just so it's clearly past it to the right. You'll press enter. If you have an actual graphing calculator, it's going to say, it's probably going to have you say, it'll say guess question mark. Just press enter one more time, but then your answer should pop up. I'll have to do it on a graphing calculator to see really quick. On this, it says intersection. I don't know if it's going to, I don't think it's going to say that. I'll have to do it on my graph for people that have a graphing calculator, but this would be our answer. And since when we find our solutions, if you remember, we're always solving for x. We would just be interested in this first part. So like our solution would be x equals about 0.27. But that would, like, if you're interested in like the actual point, that's what the y value is. But if you were doing it algebraically, this is the solution you would get. So let me just go back to our notes just to write a couple things. So after you type these in, just remember you're going to press second trace, and then you click the option that says intersect, and then you kind of go through like the questions. But like I said, our answer from what we saw was 0.27, because we're really just interested in the x value. I mean, you could write the point if you really want to, but like if you look at all the problems we've done so far, we're solving for x, like in all these. So, but if you were like looking at like a word problem, like x is usually going to represent like your time. So maybe that's how long it took for something to happen. The y value would be like, if you're talking about like height or some other value, how much money you'd have, like would be like your quantity or whatever you're looking at. So let's just look at one more of these. So like I said, you're going to graph both sides of the equation. You're trying to see where they intersect, because that's where they're equal to each other. Like if you graph two things and you're trying to figure out when they'll be equal to each other, that's going to be the point where they cross or touch each other. So we would just graph both of these. So I'm going to go back to my calculator app. I'm going to press the y equals button. I'm going to clear each one of those lines. So like I said, when you type in a fraction, though, it is really important you put the top and the bottom in parentheses. So it realizes like it's the quantity of both of these over each other. So it's x minus 3, x plus 2. And then the second equation in this one is just 1/5. You're welcome to turn that into a decimal if it, like that's 0.2 if you'd rather type that in, but it'd be 1 divided by 5. And that should be fine. You could put this in parentheses as well if you'd like, just to be safe. But I think it would be totally fine if you just did 1/5 or turn it into a decimal. But whenever you're ready, you'll press graph. Ooh, it's kind of hard to like, and you might even have to mess with your scale, but you can kind of see it crosses somewhere around here. Like it's hard to see exactly where it crosses, but the lines get really close together and then they pass each other. So it crosses somewhere around here-ish. But we're going to do second trace, the intersect function. Just want to make sure your x's are to the left. So I'm just going to go pretty far over because like I said, I can kind of see that it crosses somewhere around here-ish, it looks like. So I just want to make sure my x's are to the left of that. And then when I go to the right, I'm going to move it quite a bit to the right because like I said, I just want to make sure it's past where they cross just to be safe. And then you press enter. If you're on an actual graphing calculator, it'll probably ask you to guess, but just press enter again. But you can see it crosses, erase, sorry, what I had before, but for this one, it crosses at that intersection. So your answer would be x equals 4.25. Like I said, you could write the ordered pair, but most of, like, at least when we're solving these, I mean, usually you're just interested in the x value. It depends what you're doing. Like if it was a word problem, the y value might be important. Like it might mean something in terms of the question, but for like in terms of solving, we're just really interested in the x values. We don't really care about the y variable. But so this is just a way too, if you want to check your answers, or this is a valid way to solve. I mean, I would ask at least, I mean, on the quiz, especially if I'm doing it in Delta Math, I might not be able to see your work. So I guess you could do this for every method, but I would make sure you can do it algebraically, like get your common denominators. It's not that bad, but this is another way to do it. Or you could use this definitely to check your answers. And obviously Desmos is a little bit nicer. I mean, obviously if you type both of those into Desmos, you can just click where they cross, but keep in mind, like in future classes, you're probably never going to be able to use Desmos on a test because obviously it opens room to cheat them, but a lot of teachers will let you use graphing calculators on tests. I don't know exactly how KJ runs her 1530. Sometimes she might, I think sometimes she gives like a calculator portion where you can use like a calculator and maybe a non-calculator portion. So some teachers too, just keep in mind if you are taking like future math classes, either here or even in college, you might have certain times where you're not allowed to use the graphing calculator as well. So don't depend on it too much, but it definitely can be nice if you're allowed to use it. So let me just go back to the notes. We'll just write that. We got that x was about 4.25. And one thing that we're gonna like, you could like sketch a picture of what you got, but I don't really care. So I'm just gonna cross that out. That's what they're kind of going with that blank graph. You can kind of sketch what you see in your screen. So that's it for our notes. Really not too bad, especially if you've been doing pretty good with our addition and subtraction and multiplication. I mean, a lot of those same skills are kind of applying to what we're doing here. More so the addition and subtraction, because that's where you had to get common denominators. So hopefully it's not seeming too bad.